Welcome to Easy Math and Secret. This video will be the first of a video series on differentiation. But before we dive into differentiation, it will be very nice if we go through the basics of differentiation. When we talk about differentiation, what do we actually mean by differentiation? Differentiation actually means finding the derivative of a given function, and by derivative we mean finding the slope of that given function. For example, if we have an expression of y to be a function of x, differentiating y actually means finding the slope of this expression y to be a function of x. And if we plot this expression on a graph y to be a function of x, we will either obtain a straight line graph or we obtain a curve. For example, if we have an expression of y to be equal to 2x, this expression is most likely going to result into a straight line graph. But if we have an expression of y to be x squared plus 2x, this is most likely going to result into a curve. So the question is, how do we find the slope of a function that results in a straight line graph, and how do we find the slope of an expression that results into a curve? So before we go into finding the slope of a straight line graph or a curve, it will be nice to know the meaning of a slope. The slope of a function is the increase in its y value per unit increase in its x value. For example, if we have a graph like this, the meaning of slope is the amount of increase it has in the y value per unit increase in the x value. For example, we have the x-axis to be calibrated like this. So if this is 0, 1, 2, 3, and 4. The meaning of slope is the amount of increase in the y value per unit increase in the x value. This is 0.1 and this is 0.2. So the amount of increase it has per unit increase in the y value. So how do we obtain the slope of a straight line graph, and how do we obtain the slope of a curve? Considering a straight line graph to be in this form, to obtain the slope of this kind of graph, we pick 2 points along that line. Let's say this is point P and let's say this is point Q. Point P is corresponding to x1 and y1, while point Q is corresponding to x2 and y2. Why the difference between the x values between x1 and x2 can be termed the change in x, while the difference between the y value of P and Q can be termed change in y. By mathematical expression, we can obtain a slope as change in y value, which is y2 minus y1, over change in x value, which is x2 minus x1. And this is also the same as dy over dx. With this expression, we can easily obtain the slope of a straight line graph. And now, how do we obtain the slope of a curve? For example, we have a curve in this manner. So to obtain the slope of a curve is obtained at a point. So to obtain the slope of a curve is calculated at a point. And to do that, we find the tangent to that point. Let's say this is point P. To obtain the slope of this curve at point P, we find the tangent to the curve at point P. So, and a tangent is a line that touches the curve at only one point. So let's say, so this is our tangent to the curve at point P. Now to get the slope of this curve at point P, we find the slope of this tangent. So we can easily pick two lines along this tangent and we take that as the slope of that curve at point P. And to find the slope of the curve at another point, we just pick a tangent to our curve and we find the slope of that tangent. The reason the slope of a curve is calculated at the point is because the slope of a curve changes from point to point. For example, if we have a point Q to be here, to be at this point, and if we are to calculate the slope of this curve using these 2 points, we are going to have a line like this. And in another example, if we put our point Q to be at this point, let's say this is Q1 and this is Q2. If we are to obtain the slope of this curve at this point PQ2, we see that the slope of the curve at point PQ1 is different from the slope of the curve at point PQ2. So because of that reason, the slope of a curve is usually obtained at a point by finding the tangent to that curve at that point, then obtaining the slope of that tangent. By further evaluation, if we take our point P to be corresponding to x1 and y1, and point Q1 to be x2 and y2, so that means the difference between point P and Q1 is going to be our delta x. If the point Q1 now move to point Q2, we see that the difference between the x values and the y value is going to reduce. For example, in the first case, our delta x is from here. Our delta x is from here to here in the first case. Now in the second case, our delta x is from here to here. So we see that as Q is moving closer to P, then delta x is reducing. That means delta x is approaching 0. Also delta y, if this is our delta y in the first case, from here to here, this is our delta y, and in the second case, this is our delta y. We see that as Q is moving closer to P, delta x is reducing, and that means delta x is approaching 0. Also, delta y is also reducing, delta y is also approaching 0. And we now see that as Q is moving closer to P, the slope of the lines is approaching the slope of this tangent to point P, which is a straight line. For example, if we have another point Q3 here, we see that the line is going to be in this form. So that means as Q is approaching P, delta x is approaching 0, delta y is also approaching 0, and the slope of the graph is approaching the slope of the tangent at point P. If we take the slope of the curve to be delta y over delta x, and the slope of the straight line graph from here to be the y over the x. So as delta x is approaching 0, which is reducing, delta y is also approaching 0, which is reducing, and then the slope of the curve is approaching the slope of a straight line. That means delta y over delta x is also approaching the y over the x. Now to find the slope of a curve using this mathematical expression, we tag the y over dx as the slope of a straight line, but delta y over delta x as the slope of a curve. Now to relate them, we can say delta y over delta x is equal to y2 minus y1 over x2 minus x1. Now from here we can see that our x2 minus x1 is still the same as delta x. Now to express this expression in terms of x only, we can see our y1 is the same as function of x, and y2 is a function of x plus delta x. And we can also say x2 minus x1 to be what? Delta x. So to factor this back into this expression, we have delta y over delta x to be equal to a function of x plus delta x minus y1, which is a function of x, then all over x2 minus x1 is delta x. So we have delta y over delta x to be function of x plus delta x minus f of x all over delta x. From this graph, we see that as delta x approaches 0, delta y also approaches 0, and delta y over delta x approach dy over dx. That means as delta x is approaching 0, which can be written as limit as delta x is approaching 0. So as delta x is approaching 0, delta y over delta x is approaching dy over dx. So as this is approaching 0, then delta y over delta x is approaching dy over dx. Now we have this f of x plus delta x plus f of x all over dx. This expression here is the expression that is used to find the derivative of a function using the first principle. So in our next video, we'll be looking at how to find the derivative of a function using the first principle. Don't forget to subscribe to this channel and give your reaction in the comment section below. I will see you in the next video.